A critical aspect of building a successful application is good error handling. If you build a program that doesn't have good error handling, it doesn't matter how cool it is. If it crashes all the time, no one's going to want to use it. So we need to make sure that handling errors appropriately is really kind of implicit in our application development. Now, traditional mechanisms would use things like error codes that had to be checked or flags that had to be checked. And that's really intrusive, right? Having to put if statements all over the place to deal with potential errors really kind of clutters up your code. It's really kind of awkward. And very often as developers, we just kind of never get around to doing it. So we need a way that makes it really easy to manage errors. And that's where exceptions come in. Exceptions provide a non-intrusive way to signal errors. So with exceptions, rather than actually have to check for errors all the time, we can write our code so that we expect things to go well, but if an error occurs, an exception is what we call thrown. So when an exception is thrown, we can handle it. And that's where try, catch, finally statements come in. Is that try, catch, finally provides a structured way for us to handle exceptions. The try portion of the statement contains all of the normal code. It's the thing we expect to go well. And if all goes well, the try block will simply run to completion and nothing special will happen. But if there is an exception, control is then handed off from the try block into a catch block. So our error code is all inside of a catch block. And the catch block is only called in the event of an exception being thrown. And then we have what's called a finally block. And finally block is for those scenarios where you need cleanup. The finally block runs after your try block finishes or after a catch block finishes. So if there's anything you want to have done after the process is over, you put that in the finally block because it's assured to run whether the try block finishes completely or the catch block had to step in and deal with an error. So let's see what this looks like. Let's look at a really simple case here. So we'll have a couple of integers declared here. I has a value of 12 and j has a value of 5. And all we want to do is we're going to take the value of j, subtract 2 from it, then divide that into I. We'll store that in the result and simply print it out. Right? So in a real simple case like we have here, if j has a value of 5 and I subtract 2 from it, right, of course I have 3. So if I divide 12 by 3, I'll print out the value 4. Right? Very simple. But let's make a really small change here. Let's change j from a value of 5 to a value of 2. Well, now if I subtract 2 from 2, I end up with a value 0. It's not legal to divide by 0. So what would happen in this code is that as soon as I try to divide by 0, my program would just crash. What we want to do is code our programs up so that we can recover from scenarios like this, and that's where exceptions come in. We can wrap this code up so that we can handle the exception that occurs when we try to divide by 0. So we take our core code here, which is where we do the math and print it out. We wrap that in our try block, and then we add a catch block to it. And notice that the catch block receives an exception. In the case of an error, that variable e will receive a reference to the exception that describes the error that occurred. We can do a number of different things with the exception. The simplest thing we can do is simply print out a message that goes with it. The getMessage method gives us back the appropriate message for that exception. And if we want to, we can even print out a stack trace showing exactly what went wrong. Now our program will continue running just fine from here. But if we didn't handle this exception when that divide by 0 happens, again, we would have crashed and the user would just been left kind of wondering what happens. But in this case, because we have proper error handling in place, when we try to take that 0 and divide it into I, that raises as an exception. So control was immediately passed from where we tried to do the arithmetic that failed to our exception block, and then we can simply print out the value of that exception, the message for it, which says error, divide by 0. And then we would see the stack trace underneath of it. So that's really kind of our simplest kind of try-catch scenario. Let's look at a little bit more involved one. Let's say we have a text file that has a series of numbers inside of it, and we want to go through and just total them up. So this text file numbers.txt has the set of numbers we want to go ahead and add up. So let's write some code to do that. So we're going to take advantage of one of the built-in Java classes called Buffered Reader. And the Buffered Reader provides an efficient way to read content. We'll also have a variable called total that will hold the total of the numbers that we add up. So we'll go ahead and create an instance of our Buffered Reader. Now notice our Buffered Reader uses a file reader. Now a file reader is a built-in class that takes care of the details of reading content from a file. Buffered Reader is something that adds some buffering on top of that to make reading from the file more efficient. It also provides some helper methods. Another thing to notice here is that when we identify the name of the file, Notice we're putting // in there. In Java, / is used to identify special characters. So // says, no, I really want a slash. Now when this is done, we have an instance of our buffered reader with a reference to it assigned into the variable reader. And then from there, we're going to declare a local variable called line that will hold a string. And then we'll put a while statement in place here that actually reads from the buffered reader. So a couple interesting things are going on here. Notice that we're actually assigning to line directly inside the while statement. Right? So reader.readLine is defined to say that it will return back a null when you hit the end of file. So we take whatever we get back from readLine, assign that into line, and then we check line against null. So as long as line does not contain the value null, we know we still have content. So here we'll just go ahead and say total plus equals, and then we use one of the primitive type wrapper classes, integer, and call its value of method to convert the string contained in line into a number. Right? So for the first line in our file, we would then be adding in the number 5 into our total. When the while loop completes, we'll go ahead and print out our content. And so that's our core effort. That's what we're doing now. We're reading from a file, getting each line from it, converting it into its integer value, adding it to a total, and printing it out. Now there's a lot of things that could go wrong here. Maybe the file doesn't exist. Maybe just some kind of system error occurs when we try to read from the file. Maybe there's bad data in the file, and somebody put the letters X, Y, Z in there instead of numbers, so that could go wrong. So there's a lot of things that could happen here. So we certainly want to wrap this into a try block. We'll go ahead and put our catch block in here as well, handle the exception, and we'll print out the error message. But now something to note here. We've explicitly opened our file. When you open up a file, you need to make sure you close it when you're done. And we want to close the file whether the try block completes without any problems, or if an error occurs and we have to go to the catch block. So that's where finally comes in. So we put a finally here at the end, and we're going to put inside of there is reader.close. So we'll be sure to close the file whether we have a problem or if everything completes fine. Now something to note here. Notice that when we declared buffered reader, we declared that before the try block rather than declaring it inside the try block. The reason we did that is because we need to have access to the variable reader down in our finally block. Had we declared reader inside of the try block, we wouldn't be able to see it in the finally block. Because remember, we talked about earlier in the course that when a variable is declared inside of a block, it's not visible outside of that block. So that's why we declared that before the try block. Now another thing to note, as we mentioned, there could be different kinds of errors here. So if we run into a problem reading the file, if there's bad data there or some error occurs in the process of reading the file, our reader would still have a valid reference to the buffered reader. But what if the file we identified there, numbers.txt, if it didn't exist? Well, an instance of buffered reader would have never been created, therefore reader would still be null. So one of the things we generally want to do inside of a finally block is anytime we're going to clean up a resource, make sure it actually has a valid reference. So we check reader and make sure it's not equal to null before we close it. Now another thing we have to think about. The method reader.close is defined that it itself can throw an exception. Something could go wrong in the process of trying to close that file. So we actually need to protect the close with a try catch. So we can go ahead and wrap that up with a try block and then have a catch which will print out that error message. Now chances are you're probably not going to run into a problem closing the file, but it could have happened. So you see here that this idea of try, catch, and finally can actually become pretty sophisticated, taking care of a lot of different scenarios for us, but still allowing us to keep our code very structured in how we deal with each aspect of it.